Now let us see the rules about BCD subtraction or subtraction of two BCD numbers. So let us go through the rules first. Rules to follow: it's a simple binary subtraction. Second rule is, if the result or the difference what your operation you're performing, see, though it is called as subtraction, we are not actually performing the subtraction, we are finding out the actual difference between the two bits. So if the difference or result whatever you say is less than or equal to 9, then it's a valid BCD number. That is your rule number 2. And if the result is greater than 9 or the borrow is required from the next group, then it is a invalid result. Hence subtract 6 from the result. So let us find out with the simple examples. First of all, we will perform very simple example. We will perform 9 decimal minus 6 decimal. So required answer is 3 in the decimal format. This is the normal decimal subtraction. We will convert this into BCD subtraction. So let us write down 9 and 6 into their BCD format. And you need to subtract these two numbers. So let us perform the subtraction. So 1 minus 0, the difference is 1. Now be careful while solving the next group. It is 0 minus 1, so it will not be minus 1. We are calculating the difference. So difference is 1, but still this 0 is somewhere smaller than 1. So it needs a borrow. And if you'll take the borrow, it will take the borrow from the 0, but still it is a 0. So what we will do, instead of decreasing the value of this 0, we will add 1 in the lower number. It is going to be the 1 and the same thing, whether to decrease the upper number or to increase the lower number while subtraction. So this is what we will perform. So this is 0, 1, answer will be 1, borrow will be needed, so we'll add 1 here exactly below the lower number. And now we'll perform again the simple subtraction. So again 0, 1, the difference is 1, 1 and this borrow 1, the difference is, total difference is 0, but still it required a borrow from the earlier bit. 1 minus 0 is 1 and 1 minus 1 is 0, so final difference is 0. So this is a number which is less than 9 if you convert into straight binary code, and hence it's a valid BCD code, and the answer is 3. Let us take the next example. 82 decimal minus 54. So the answer is 28 decimal. Now let us write down this 82 and 54 which are in the packed BCD format. So we will obtain 8 and 2. Similarly, this is 8, 2, 5 and 4, and we need to subtract these two numbers. So let us subtract them going from right to left. 0 minus 0, 0, 1 minus 0 is 1, 0 minus 1, the difference is 1, borrow needed 1, 0, 0, 0, 0 minus 1, difference is 1, borrow needed 1, 0 minus 1, borrow needed 1, difference is 1, 1 minus 1 is 0, 0 minus 0, 0, 0 minus 1, difference is 1, borrow needed 1, 0 minus 1, borrow needed 1, 1 minus 1 is 0, and this 1 minus 0, 1, 1 minus 1, the total difference is going to be get 0. Now if you check carefully, the right group is invalid BCD. So what we need to do, subtract 6 from their right group to get the valid BCD number. So what I will do, I will subtract 6, that is 0, 1, 1, 0 from this group to get the valid answer, and the group towards the left which is kept as it is. So let us perform the subtraction. 0, 0, 0, 1, 1, 0, 1, 1, 0, 1 minus 0 is 1, and this group is kept as it is, so it will be 0, 1, 0, 0. Now both the numbers are of valid BCD code. This represents number 2, this represents number 8, so your final answer is 28 decimal, and this is your BCD code for the respective operation, 82 minus 54. So that is very simple, BCD addition and BCD subtraction. And let me clear your doubt, why we are adding 6 or subtracting 6 from the BCD addition and the subtraction respectively. So these are all the BCD numbers, and to represent the largest BCD number you can say is 9, so it took me 4 bits to represent. So from 9 onwards 0, I will represent all the numbers in 4-bit pattern. But you have 2 raised to 4, that is nothing but 16 combinations. 16 combinations, and they are as follows, starting from 0000 to 1001, and along from 10102 to 1111. Now this 00002 to 1001, that is nothing but 0 to 9, these are the BCD numbers, but still you have 6 combinations that are not used in BCD, and you need to skip these 6 combinations, that is from 10 to 15, or you can say A B C D E F if you convert into hex. So you need to skip these states, you need to skip this 6 state to again go through the valid BCD, that is nothing but the 0. That's why we are adding 6 in the addition and we are subtracting 6 in the subtraction. So this is all about your BCD arithmetic. Thank you.